Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm going to talk about GMV6 heat recovery, the outdoor unit, the internal equipment. As you can find that the cases of this outdoor unit is the same as GMV6 heat pump. You can also refer to the GMV6 heat pump internal equipment video for detail, and you may find that there are lots of the components similar or the same. This is the piping diagram for single compressor. You can find it's very complicated, right? This is the outdoor unit, although there is only one compressor, but it's quite complicated enough. Actually, you can say that this is the most complicated system in our grid. And for this diagram, there are two mode exchanger with 4 indoor units. I will explain or introduce the inside components one by one for you to better understanding. This presentation divided into these 4 parts. The first part is sensors and switches. First is the temperature sensor, also called thermistor. Its function is to detect the temperature because itself is just a resistant, which the resistance value is very sensitive to the temperature, which means if the outdoor ambient temperature change, then it will also change the resistance value. And just like this picture, you can find that actually this one is the thermistor. And then the PCB will check this resistance change value, which means if the resistance value change and then the detected voltage also change, which means the PCB can get the information. And on the system, you can find the temperature sensor. This one is for to detect the environment temperature, which is the outdoor ambient, and this is the indoor pipe temperature. Just like what I said, when the temperature change will lead to the resistance value change, then the PCB detected voltage also change. Then PCB can get this information, and then according to the information, the PCB will adjust the parameter and also make the to change the parameter and achieve control. Inside the GMV system, there are 3 types of the temperature sensor, which is the 50K ohm. It is for the high temperature located at the compressor discharge and also the compressor top cell. Next is the 15K ohm to detect the low temperature, which is the outdoor or indoor room temperature. The last is the 20K ohm. It's for the medium, which you can find lots of the temperature sensor on the piping, including the defrosting and the subcooler liquid out and gas out, and also for the indoor unit, the pipe in and pipe out. And from this curve, you can find that here is the temperature, this is the resistance, and when the temperature change, the resistance of the temperature sensor will just follow this to change. And on side, you can check the resistance value, whether it is close to this detected value. And by the way, why we call it to be 15, for example, 15K ohm is because when the outdoor ambient or the room temperature is 25 degree, the detected value is 50K ohm, so we will call it is 15K ohm. This slide displays how the system will apply the detected value, and the application is for the compressor discharge. As you know that for the compressor, it should avoid overheat, because if the compressor become too hot, it will make the inside oil to be decomposed, which will shorten the compressor lifespan. And the temperature is about 130 degrees. So we put the sensors on the compressor where it is the hottest, which is the compressor discharge or the compressor top cell. And also at the surface, we apply the thermal grease to make it good contact with the pipes or the compressor top cell, just like this. And also use metal plumb to make it to be good contact. And also when we detect it, the temperature is higher than 102, we will increase the EXV opening pulse. The purpose of this is just to increase the compressor flow rate to cool down the compressor. The next is when we detected the 112 degree, and then we will lower the compressor RPM. If it is higher than 120, we have no idea, but just shut down for protection. Next, we will go to the pressure sensors and switch. This is the outdoor unit diagram. It just had the basic components. And we have the pressure sensor, which is high pressure sensor located here between the four-way valve and the oil separator. And with a red color plastic bag, there is the high pressure sensor. Also, a high pressure switch or high pressure circuit breaker located at the compressor discharge. And low pressure sensor located at the entrance of the gas liquid separator, which is at the suction side of the compressor with a blue color plastic bag. This is the low pressure sensor. First, we will talk about the pressure sensors, and its working theory is similar to the temperature sensor, but the detected item we change to be the pressure, and also when the pressure change also leads to the inside resistance value change, and then the detected voltage also will change. Then the PCB can get the information, and according to this one, it will change the parameter like the compressor RPM and fan RPM and EXV opening for system control. And on the actual unit, here is the pressure sensor. This is the service port, and here is the valve body, and this is the pressure sensor, which is this one. On side, we just connect here to get the pressure information, which we will get this graph, which this is the pressure and here is the voltage, and according to the pressure change, also the voltage change, then the PCB can get the pressure information. Pressure switch, and in the system we adopt the normal closed tie located at the compressor discharge, and here is how it works. The key component is this one, movable contactor, and when we detected the value higher than our preset value, it's about 4.2 megapart, then this movable contact will just going up and also make this to be open circuit, and then the system according to the open circuit will also make the reaction, which is to stop the system. And also you can check the value on the pressure switch just like this, and this 4.2 means the 4.2 megapart for break off, and 3.6 means the reserve pressure 3.6 megapart. And also if you change this pressure sensor, and after that please fasten this part. This is just to prevent the vibration of the compressor, as it will vibrate a lot, and this is to make it to be fastened.
That's all for this part of the presentation. If you still have any other question, just feel free to contact me on my personal email address.